Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in computer science. In today's session, we are going to see about the different types of functions available in C++. The functions include the way we call a function, the way we execute a function, and how control is passed on to the function. Functions and parameter passing, inline functions and static member functions also. So, when we consider first the basic functions that are available in C++, it is similar to what we have already seen in the programming language C. So, just a brief introduction into the concept of functions. They are defined as a set of statements to accomplish a certain job. It may not be the entire program's work, but a small subset of the entire work that is to be done. And in C++, they are referred to as member functions because everything in C++ involves classes and objects. So, when a function is defined inside a class, it is called the member function of a class, and in general we call that functions. Functions can be of two types, one is with arguments and without arguments. Now, all this we have seen in detail in C. We will now be seeing how they are executed with respect to C++. So, member functions with arguments, the way they are invoked. Invoked is nothing but the way we call a function. See, there exist functions to do a certain job, but it depends upon the user to decide when that particular job is to be done. So, when the user decides when the job is to be executed, he has to find out a method to call that particular function. There are two ways to call a function. One is using call by value, the other is using call by reference. Now, we will see how these two are executed in C++. Now, what are the basic features of the call by value method? The called function creates a new variable of the same type as the argument. So, whatever function involves, whatever data members the function involves, it creates a new copy of that. It creates a new copy of those parameters. It copies the argument value to the new variable. So, there is only one argument, but it creates another copy of that, and the value of the actual argument is passed on to the argument that is newly created. This is useful when the function does not need to modify the values of the original variables in the calling program. So, now again here also there is one variable with a value, we make another copy, you can call it a duplicate of the original variable, and whatever the function performs, whatever job is being done by the function is done only to the copy of that old variable. So, the actual variable's value is not affected in this context. Now, in call by reference, it is an entirely different issue. There are two ways we can execute call by reference. One is using the alias. Alias, as we all know, is another name for a variable. By creating another name for the existing variable, we can perform call by reference. So, this gives two names to a variable using the alias operator. Another one is using pointers. Pointer is nothing but a variable which holds the address of another variable. So, the address of the actual parameters are sent to the called function. The called function is a function that is to be executed. Any change that is made to the formal parameters are permanent. Formal parameter is nothing but the new copy of the variable that is created. The actual parameter is the existing variable, the formal parameter is a new parameter that is created. So, the actual parameters and the formal parameters, their values are changed in this particular method of function execution. So, this is the difference between the two types of function execution. In the call by value method, only the copy of the variable is affected, the actual variable is not affected. In call by reference, the actual value of the variable is also affected when the function is called. So, now we will see an example program of how call by reference is executed using the alias operator. So, here you are having a function called class call, you are having a integer variable n. Now, we all know that the default access mode is private in the case of C++. So, because no access mode is specified before the variable n, it is meant to be of type private. So, it is a private data member of the class call. Next, you are having the public access specifier, and you are having a function called disp inside this class. So, here the class is closed with a semicolon. So, in class call there are two parts, one is a data member called n, the other one is a function called disp. The data member is private and disp is public. So, now outside the class we are giving a definition for the function disp, what that particular function is supposed to do. Now, in this particular function we are giving a value to that variable n. We all know that n is a variable in the class. So, we are giving the value 5 to that variable n. Next, we are creating the reference or alias for that variable n, because we are going to execute the call by reference method of function execution. So, we need an alias for the actual variable, that is a copy, another name for that actual variable. So, integer, we are using the address operator ampersand. Here we are using the address operator ampersand. We are having the alias an and we are initializing it to the variable n. So, this is the way we use the alias operator. So, here the alias operator is also an ampersand symbol. We are giving a name an and we are initializing the value of that an to the value n. So, n is nothing but it has the value 5. So, a reference or an alias when it is created should always be initialized to some value. It cannot just be declared. Like we declared integer n, we cannot simply declare integer an. Using the alias operator, we should always give it an initial value. So, here we are initializing the value of the alias to 5. Next, we are using the cout statement. In the cout statement, first we are displaying the value n, that is the original value n, which holds the value 5. And next we are saying alias and we are displaying the alias value of that variable. The alias is nothing but an and we are displaying its value. Next, we are incrementing the value of the original variable, that is n, with the original name. We are incrementing that value by 2. So, now the value of n becomes 7. So, now if the alias is successfully declared to be another name for the original variable, the value of the alias also should change. So, next we are displaying the value of cout n as well as its alias an. And again now we are incrementing the value of the alias by 4. So, here if you see in the first step, we are incrementing the value of the original, with the original name we are incrementing the value of the variable. In the next case, we are incrementing the value of the alias by 4. So, in both the cases, if the creation of the alias is successful, the value of the variable should change. So, first the value displayed should be 5, after it is incremented by 2 it should become 7, and when it is incremented by 4 it should become 11. So, if this is the output, then our program execution is perfectly correct. So, now next we are displaying the value of num as n and the value of the alias as an. So, from the main function now we will call all these functions and see whether the values are displayed correctly. So, as we all know, the execution of the program starts from main. We are having only one class called call, and this is the way to create an object for the class name followed by the object name. So, OB1 is the object over here, and using OB1 we are calling the display function. So, as soon as the display function is called, it will initialize the value of n to 5, then it will increment it by 2, then by 4. So, if you see, the output is perfectly right. First we have 5, then we have 7 and then we have 11. So, this is how an alias is created with regards to call by reference method of function execution. Now, these are the points to be noted in call by reference execution. After a reference variable has been defined to refer to a particular variable, it cannot refer to another variable. This goes without saying. We cannot use the same alias name for 2 or more variables. We have the original variable. When we initialize that reference to one particular variable, we cannot change its reference to another. So, this is to be kept in mind when we are executing functions using this alias method. And a variable can have more than one reference. Now, with regards to the program that was given as an example, n was the original value. This n can be made to reference many other variables. For example, we can have 2 or 3 names for that original value n. But for the alias an, we cannot make it to reference more than one variable. So, the original variable can have different names, but the different names that we give for that one variable cannot be made to point to many original names. That is to be kept in mind. It is not an associative or commutative type of property. Changing a value of one of them affects a change in all the others. So, when you create 2 or more references for one variable, when you alter the value of any one of the references, all the values of those variables are changed. So, this we have to be careful in case of data inconsistency, like when you are having several names for one particular variable, if you change any one value, it will change all the values of those variables. So, in that case, when we change the value, we have to be careful in the case of a variable, otherwise we may think that it is having one value and we may lose track of the references that we have created, which leads to data inconsistency. So, that is the point to be kept in mind when we are using this alias operator. That is why mostly when we execute call by reference functions, we normally go in for the method of using pointers, where we hold the address of the variable. Next we go into inline functions. So, inline functions is available only in C++, is the first time we are going to study about this. So, let us see their definition. Inline functions indicate to the compiler that the function body needs to be inserted at the place of the function call. See, so far we have seen that whenever a function is called, the control goes to the function, it executes a function, then it returns to the object which called it. But in the case of inline functions, it indicates to the compiler, or it gives a direction to the compiler that the entire body of the function has to be inserted at the place where the object or a particular function calls another function. The function call is replaced by the function definition in the calling place. Using the keyword inline only, we can declare a function to be an inline function. So, wherever you declare the function, whether you declare it or you define it or you give it as a prototype also, it is always better and a must to use the keyword inline. That is what differentiates this inline function from all the other functions. Now, how do you declare it? You have to use the keyword inline as it is mentioned over here. The keyword inline is very important. The return data type, this is normal for all the functions, whether it returns an integer value or a float, or if there is no return type, we declare it to be of type void. Then you have to give the return data type and the function name followed by the arguments. A function may or may not have arguments, this is optional. And then you give the code. Code is nothing but what job that function is supposed to be doing, that we have to define it in terms of the programming language syntax. An example for this, you are having the inline keyword, you are having the float return data type, cal is the name of the function, two integer types arguments, integer x and integer y, and inside the inline function you are just having one statement, return the product of x and y. So, this is how inline functions are to be declared and defined. Now, what are the points to be noted when we are defining this inline function or using it in a program? Why at all do we need these inline functions? The process of replacing a function call with the function's code is called inlining. This is a term that is used with inline functions. So, when the entire body of the function is inserted at the place of the function call, that particular function or that particular program is said to have inlined functions, and the process is called inlining. When the compiler performs this particular task of replacing the body of code, the function is said to be inlined. These functions generally need to be small sized functions. This is very important because if you are going to replace a big function, say a function having 100 lines at the place where it is called, it is going to greatly increase the size of your program. So, when the size of the program increases, the number of complexity enters the program, like the time taken to execute the program, the memory space required by the program. So, instead of making it more efficient, we make it a more inefficient piece of code. So, generally when we go in for inline functions, they should definitely be very small sized functions. Even in the example we saw, it was only a single line, return x multiplied by y. So, such types of functions only are meant to be inline functions. This eliminates the overhead only when the functions are short. Overhead in the sense the time that it takes for the compiler to transfer the control of the function from the object which called the function to the function which is being called, that is only called the overhead, that extra time that it takes. So, if that extra time is to be reduced, then definitely the inline functions have to be small sized functions. So, this is the concept of inline functions. This is generally used only with regards to C++, and without using inline functions also we can execute a program. This is only an extra option which is available for the user. About the static members and member functions we will see after the break. Welcome back after the break. In today's session, prior to the break, we had been seeing about the functions in C++, what are the different types of invoking the functions, and the new concept of inline functions, how we try to eliminate the overhead of passing control to small sized functions by simply inserting them at the place of the function call. So, now we are going to see about static members in C++. So, something that is static in nature is something that does not change or which holds the memory for a longer period, like whatever change has been done to that particular member or variable, That change is kept in mind, is kept in memory for a long period of time or till it is needed. So, how does this concept of members and member functions enter and make its use in the C++ programs? Now, in static, when we use the keyword static, there are two types. We have both variables, that is data members, as well as static functions. So, how do we execute these members and what are they used? In what types of applications they are meant to be used? So, first we will see about the static member variables. These retain their value even after the function to which they belong has been executed. So, generally when we create variables for function execution, once a function is executed, those values go out of scope, they have no meaning. But here in the case of static variables, when we want some value to be held in memory for a longer period of time, even after the control comes out of the function, then we declare such variables to be static variables. All objects of the class share one copy of these variables. Now, generally when we see about inheritance and concept of instantiation, where objects are created for a class, we know that a class has members as well as functions. All the objects of the class share the same copy of the member functions, but they have a different copy of the data members. Whereas in the case of static variables, all the static data members of the class, all the objects have only the one copy. So, any change that is made by any object of that class to that particular variable, it has to retain its value. So, this is a point to be kept in mind when we create many instances of a class. All the objects will have only one copy of the static member. Static variables can be initialized outside the class definition or inside a member function. See, because these variables retain their value, the place where they are declared actually has lesser meaning, because wherever they are declared, when they are first assigned a value or any operation is done on them, they retain their value. So, they can either be declared outside the class definition like global variables, or they can be declared within the function. Even if they are declared within a function, after the function is executed, they still hold on to their value. Now, we will see an example of how these static members are declared. We are having a class, the name of the class is SE. We are having a integer variable data. There is no access specifier over here above data. So, it is meant to be of type private, because private is the default access specifier. So, this data is the integer variable of this class, which is of type private. Next, we are having another integer variable of name var, but this is declared to be of type static. So, just like these inline functions, when we declare a variable to be a static variable, we have to use this keyword static. Next, we are having the public access specifier, and we are having some functions over here. Here it is not important, because here we are studying about the data members only. And this is how the value of the variable is initialized. Integer is the return type of the variable, integer is the return type of this variable, SE is the name of the class, and var is the name of the static variable, and is initialized to 0. So, here we have declared, this is only the declaration of the variable. Now, here is where we are actually initializing its value. So, this is how static variables are meant to be used in the C++ programs. Next, we go on to static member functions. Now, the reason why I stopped with the small program is static members actually have their value only when we declare static member functions. So, that was only an example to show you the syntax of declaring a static data member. So, now we will see about the static member functions and how they both work in coordination. So, static member functions, they can access only static variables. They are not like general functions of C++. Normally, a function of a class can be accessed by any object of that class, and that function can access any data member of the class, whether it is private or public. That is the actual power of functions in a class. But when we declare a member function to be static, those powers that function has to relinquish. It can access only the static data members. It cannot access any general variables of a class. This uses the class name to access the static functions. So, even to access the static functions, it has to use the class name in which it has been declared. The syntax is like this: class name followed by the scope resolution operator and the static function name. This is how the static functions are called and executed. Now, we will see an example of these static members and static member functions. Here we are having the class EX, the name of the class is EX. We are having an integer variable D. We are having a static integer variable I. Both of these do not have any access specifier, so they are of type private. Next we have the public access specifier, and here we are having only a single function disp, which has no return type, it has only a void return type, and this is declared to be of type static. So, static is the type of function, void is the return type, disp is the name of the function. So, here itself we are defining what that function is supposed to be doing. That function is supposed to be displaying the static variable I. So, this static variable has been taken from this part. This is perfectly allowed because a static member function is supposed to access only static variables. But here if you see, it is also displaying the variable D. Variable D is not a static variable. So, this will definitely lead to an error in the program. This is because static member functions can access only static variables, D is a normal variable, I is only a static variable. So, if this type of access is allowed in the programs, it will lead to an error. So, if we want to display both the values of the variables, then we have to define another function and display the value of D, or we should not declare this particular function to be static and we can display this variable D. Now, this is how the static variable I is accessed. Now, there we saw that the value of the static variable was only declared static integer I. Here we are having the return type int, we are having the class name ex followed by the scope resolution operator and the value of the variable I, and then we are initializing it to 0. So, actually the value of the variable is initialized only over here. After this, when we call that static member function only, it will display the value of this variable I as 0. So, the actual execution of the program starts from main. You open the main function and this is how you call that particular static member function. This is the syntax to call it. Even before creation of the object, normally so far we have seen that when we have a class, inside that class, inside the main function we have to create instances of the class, that is only called instantiation or objects of the class, and using that object only we access the member functions, and through the member functions we manipulate the data members. This has been the normal hierarchy so far. But here we are seeing that ex is the name of the class, we have not created any object for it. Before creating the object itself, we are able to access the member function only because it is of type static. If it was a normal function, this is not the way to access it. So, this is the speciality of these static functions. They are static in nature, they retain their value, they access the static members, and even before the object creation, these static member functions can be called. So, this is the concept of static members and static member functions in C++. Now, what is the importance of these inline functions and static functions which we have newly seen in C++? Inline functions basically reduce the overhead. Like when you have to execute a particular function, the normal procedure is you have a function name, you have the function prototype, you have the function declaration, then you have the function definition, and from some particular place wherever you need that particular job to be done, you create either an object and you call the function, or inside another function you call the function, which is called recursion. So, in this case there is a lot of time that is involved and lot of memory space bringing in data and taking out data, because when you want to execute some particular program, the data on which it works has to be present in the memory at that time. So, when you are passing control to a function, there are a lot of internal workings that are taking place in the system. So, the overhead that is incurred in bringing data into the memory, getting it executed, storing the result, sending it back to the function which called it, then taking out the memory, passing control to the function and executing it, all this adds complexity to the program. So, in order to avoid this problem of passing of control, in the case of inline functions, when you have small sized functions where the function is needed, wherever there is a function call, the entire body of the function just comes into the program, it is just inserted like that. So, the program continues as a sequence, you do not have to keep jumping between places. So, that is the reason we move into inline functions. In the case of static functions, normally the scope, we have already seen what is scope of a variable. A scope is the time for which its value is available. So, when the scope of the variable needs to exceed the lifetime of the function or exceed the time when the function is to be executed, mainly because that variable might be required somewhere else in the program, or it might be used by some other function also. In such cases, we move into these concept of static members and static member functions. So, and the usage of this alias operator in C++, it is a new concept which we have not seen in C. The other two, call by value and call by reference using pointers, has already been discussed in C. That is the reason the example programs were not given. So, this alias operator also is generally not a very commonly used type of call by reference in C++. When we use call by reference, we normally manipulate them only using pointers to avoid the problem of data redundancy and data inconsistency. See, when you go on creating different names for the same variable, it is only going to confuse you about which variable has been given a different name. In the example that we saw, we had only one variable. So, for that one variable we can create any number of names, because we know that whatever name we manipulate, it is going to manipulate only that variable. But generally in C++ programs we may have plenty of variables, 10 or minimum of 5 variables. If we go on keep on increasing the names of each of them, it is going to lead to error on the part of the programmer, and anybody who reads the program later also will not be able to understand the program. We should always remember that when we are writing programs in C++, the readability of the program should be right, because it is not necessary that whoever is writing the program is only going to use it. Programs need to be reusable. That is the main concept of writing software. So, when we write programs, we have to make it more readable, and any enhancement to the program, the same type of program may be used as a base for some other application. So, in such cases, when another programmer is going to read it, he should be able to modify the program according to his need. So, for that reason we avoid using this alias method of function execution. So, this is the main function which called that particular disp. Example exob1, this is a way of creating an object, and using the object we are calling that function. So, both ways the function can be called. So, in today's session we have seen about this concept of parameter passing, the concept of inline functions, static members and functions, and their examples. So, what are the types of parameter passing that is available in C++? Parameter passing is nothing but call by value, call by reference. In call by reference you have this alias method and you have the method of pointers. The concept of an alias we have seen, we have one variable, we can create a duplicate name. This is not a copy, we are creating only another name for the same variable. And whatever manipulations are done to the variables, they are indicated in the original variable also. Inline functions are functions which are used with the keyword inline. Wherever the function is called, the body of the function is replaced over there. Static members, when we want the value of a variable to hold its value even out of the scope of its declaration or execution, we declare those members to be static members. So, static functions when they are used in C++, they have to be used with the keyword static. They can hold only, they can access only static variables, and they can be called even before the object is created. So, these are the final concepts in C++ that we have seen, the basics that are to be used. Beyond this, we have advanced concepts of virtual functions and polymorphism, which we will be seeing in the next sessions. Thank you.